So our final lesson about indices is we're going to look at something called a rational indice. And a rational number is just something that can be written as a fraction. So you'll notice that these have fractions. Now, we know what square root is, hopefully. So if we have the square root of 9, square root of 9 is 3, because 3 times 3 is equal to 9. So the square root of number is the number multiplied by itself that will equal the number. Square root of 4 is 2, because 2 times 2 is 4. Now, the square root of a number is equal to that number to a half. So the square root of 2 is equal to 2 to the power of a half. If you don't believe me, type into your calculator and check. They're equal to one another. Now, this symbol here is the cube root of a. So what a cube root is, so for argument's sake, if we have the cube root, so the cube root, a little 3 up here, the cube root of 8 is equal to 2, because 2 times 2 times 2 is equal to 8. So the cube root of something is the number multiplied by itself 3 times, that will give you that number. So the cube root of 27 will actually be 3, because 3 times 3 times 3, 3 times will give you 27. Now, so the general rule is this one. So if you have the nth root of a number, then it's going to be that number to the power of 1 over n. You can see the pattern. I'm going to ignore this one. So writing as single powers of 2, the square root of 2 is simply 2 to the half. 1 over square root of 2 will be 1 over 2 to the half. And then using our index laws that we know, we can flip the 2 to the top, so it will be 2 to the negative a half. This one, well, if we go to our cube root rule, this is just going to be 2 to the power of a third. This one here is this one here. So if it's the nth root of a number, so we have the fourth root of 2, we can write that as 2 to the power of a quarter. And then finally, if we want to write it as powers of 2, well, we can look at 4. What can we write 4 as? 4 is 2 to the power of 2. So this can be the fifth root of 2 to the power of 2. And then what we can do is, basically, we can raise, I guess it is this one. So if we have the fifth root of 2 to the power of 2, no, I'm going to do it the other way. So this is the fifth root of this. So the way I like to think of it, because this one's so hard to remember, that's why I'm not getting you to remember it. So this way, if we have the fifth root, okay, actually, let's do it in reverse. We have 4. We can rewrite this as 4 to the power of, because it's the fifth root, it would be 4 to the power of 1/5. Okay, and now we need to write this as a power of 2. Well, what can we write 4 as? 4 is simply just 2 to the power of 2. And then we can raise that to the power of 1/5. And then we know our index law. When we have a base and we raise it to a power, and we're raising it to another power, we simply just multiply the two powers. So we'll have 2 to the power of 2/5. So in this question, I just want you to practice using your calculator to do rational indices. So in your calculator, I want you to type in 2 to the power of 3 over 5. And you should get 1.5157 to 4 decimal places. If you're not getting that, give me your calculator and I'll show you how to do 2 to the power of 3 over 5. The second one is the fourth root of 7. So if you look at your power button, underneath your power button there is x to the square root. That is your cube root button. Not your cube root button, your nth root button. So hit shift and then power, and you'll see that it brings up that cube root button. Now, you need to put a number in front of the root button, so it's going to be the fourth root, so it'll be 4, and then shift and the root button, and then 7. and it'll give you the fourth root of 7. And you'll get 1.6266 to 4 decimal places. And then the last one is just going to be 1 divided by the fifth root of 3. So if you type that into your calculator, 1 divided by the fifth root of 3, you'll get 0.8027 for decimal places. And then the final example I'm going to do in this video is, without using a calculator, write in the simplest rational form. So just recall that a rational number is any number that can be expressed as a fraction of integers, and integers are whole numbers, or simply just as a whole number. So we're going to simplify this. Now, 8 to the power of 4/3, there's no way we can do that. We have no idea what that looks like. But what we can do is we can simplify 8. What can we write 8 as in terms of 2? It's got a base of 2. 8 will be 2 times 2 times 2, 3 times. So it'd be 2 to the power of 3. But we still need to raise that to the power of 4/3. And then if we have a base raised to a power, raised to another power, what do we do to the two powers? We multiply them. So 3 times 4/3. Now when multiplying fractions, if you have a whole number multiplied by a fraction, that whole number only applies to the numerator. So that'll actually give us 12/3. And 12 divided by 3 is 4. So that'll give us 2 to the power of 4. And then simply, 2 to the power of 4 is 2 times 2, which is 4, times 2 is 8, times 2 again is 16. And if you type 8 to the power of 4/3 into your calculator, you get 16. And then our second one, so 27, hopefully we can recognize that that has a base of 3. We're always looking for a prime number. So 27 has a base of 3. And 27 is going to be 3 to the power of, so it's 3, 9, 27. So 3 to the power of 3. And that's raised to the power of -2/3. Now again, we know that if we've got a base raised to a power and we raise it to another power, we're going to multiply them. So it's going to be 3 to the power of 3 times -2/3 will be -6/3. And -6 divided by 3 will give us -2. So it'll be 3 to the power of -2. And now, using index laws that we learnt last lesson, we can rewrite this as 1 over 3 to the power of 2. And finally, we can simplify it, and 3 to the power of 2 is 3 times 3, which is 9. It's 1 over 9. So we've simplified both of these without using a calculator into their simplest forms, simplest rational form, where either a rational number is a whole number, like our first example, or a fraction of integers, like our second number. So have I got the following exercises in your textbook on page 334. Let me know if you have any issues.